So this is a very important topic in A2, which is about the electrode potentials and the transition metals. So I'll solve some questions from this topic. First 13 questions are already recorded. So I will start with question 14. So in question 14, aluminium and iron are both metallic elements. There are similarities and differences in the properties of their compounds. Both elements form compounds in which their oxidation number is +3. Complete the electronic configuration for aluminium 3 plus ion and iron 3 plus ion using the SPD notations. So we have to use SPDF notations. So for aluminium, atomic number is 13 and iron is 26. But because we have to make for +3, so we have to arrange 10 electrons. And here, +3 means we have to arrange 23 electrons. So 10 electron, it will be 1s2, 2s2, 2p6. But in case of iron, when we write for atom, like because when they occupy, like if we write for 26, it will be 1s2, 2s2, 2p6, 3s2, 3p6, and then from 3p it will go to 4s. So that makes 20, and then there will be 3d, and because we want to make, so 3d6 will be there. This is in terms of energy, but in terms of order, the orbital order is 1s2, 2s2, 2p6, 3s2, 3p6, 3d6, and 4s2. This is in terms of order. When electron is lost, electron is always lost from the outer shell. So first, which electron will be lost? So first electron will be lost from 4s, the second also 4s, and one from 3d. So what is the configuration for iron here? 1s2, 2s2, 2p6, 3s2, 3p6, 3d5. This is a configuration for iron. So first write for an atom for transition elements. The first what you will do, you will write for an element and then convert into ions. Because the electron is not lost from the in terms of energy, it is lost in terms of order. The outer shell electrons, it will lose first. Aluminium only form a compound in which its oxidation number is 3 plus or +3. Where iron has a compound with a variety of oxidation numbers suggests a reason why iron forms a stable compound with more than one oxidation number. So why it form oxidation number +3? Like they're only forming compounds in which oxidation number is +3 for aluminium, and iron is forming variety of oxidation numbers suggests a reason why it form a stable compound with more than one oxidation number. So for transition element, what happened? There is like a very small increase in the successive ionization energies. But when we talk about aluminium, like when you Aluminium, the configuration is 1s2, 2s2, 2p6, 3s2, 3p1. So for removing the electrons from the outer shell, the energy will be comparable. But when we remove electron from inner shell, there will be a big jump. But in case of iron, as we are removing the successive ionization energies, a very small increase is there in a successive ionization energy. So as a result, like we can remove several electrons from the d orbital with a similar energy. And another reason is also there. The energy of 4s and 3d is comparable, like it's approximately same. So energy gap between 4s and 3d is very small. Like when we talk, this is aluminium, but when we talk about the configuration for iron, it is 1s2, 2s2, 2p6, 3s2, 3p6, then 3d in terms of order. So it was 3d6 and 4s2. When we remove the first two electron and the third electron is removed from d orbital. The energy gap between the 4s and a d 3d is very small as compared to energy gap between 3s and 2p. So how we summarize this, you can mention like the successive ionization energies for iron is comparable. For iron, that's why we can remove multiple electron. Or you can also say that the energy gap between the 4s and 3d is smaller compared to 3s and 2p. Like 3s and 2p is in aluminium, here, where this is for iron. Most aluminium compounds are colorless, but iron 3 compounds are colored. Explain why Fe, like hydrated iron 3 ion, is colored. So, an aesthetic question is there means the answer should be structured. So, why the ionization energy, why it form a colored compound? So, first, what will happen? Because the concept of the color is due to the splitting of a d orbital. Like we have d orbital, which is dxy, dyz, dzx, dx square minus y square, and dz square. Say they all have example 10 joules of energy, all have the same energy. But due to the presence of the ligand, what will happen? This cause a distribution. The total energy does not change. The total energy remain 50. Like example, this is an example. So total energy remains same, but the energy distributed among the orbital uneven. Like some orbital get more energy, get higher energy, and some orbital get lower energy. So example, say this get 4, this also get 4, and this also get 4. So total will be 12. So for these two, the remaining of the energy, like 50 was there, so the remaining 38 is left. So remaining maybe this will have 19 joules, this will also have 19. So the total energy divided between the orbital due to the presence of the ligand. And as a result, what will happen? When electron jump from one orbital to another, like it absorbs certain energy and then release, that is responsible for giving a characteristic color. But how you summarize this, how you write, like this is explanation, but exam point of view, how you will write the answer. So first thing you will mention the 3D orbital split, the energy of the 3 orbital split due to the presence of the ligand. That is a one point, the first point. Then the second thing, what will happen? Because first it will absorb energy. So electron absorb energy, or you can also say photon, and it which is equals to, like, electron absorb a certain amount of energy and it transit from lower shell to higher shell, because when it absorb energy it will jump to higher shell. That is how, like, line spectrums are also formed, if you remember, in AS physics. So energy is absorbed by the, and it jumps to higher shell, or orbital, you can also say, or jumps from lower orbital to this. These are the 2 points. One is energy absorbed by electron, or you can also say a photon is absorbed by an electron, and it causes a transition of electron from lower orbital to higher orbital. Then what will happen after this transition? How it result in a formation of a color. So the color which is transmitted, like, remain in the light, that will be in the visible region. So it's not like what color is not absorbed, that will be seen. Like example, we have a white light which is a combination of violet, indigo, blue, green, yellow, orange, and red. So what is absorbed is not seen, what is not absorbed is seen, like, or a complementary color will be seen. So the fourth point is the transmitted or a reflected or a remaining of a light which is colored, or it is in a visible region. So we'll see a complementary color. So that's how you will score the marks, the 4 marks. 1 mark is for mentioning the presence of the ligand causes splitting of a d orbital. Second thing, when electron in the lower d orbital absorb energy, it jumps to a higher. So 1 mark is for mentioning absorption, 1 mark is for mentioning jump from lower to higher. And then it is the what is seen, the color which is visible, that is the transmitted one, or you can also say the reflected one is visible. Is it clear, this question? How you explain the formation of a colored compound by the transition elements? Moving on to the next question, aluminum ions and iron 3 ions form complexes in solution. These solutions are acidic. Draw structure of hydrated iron 3 complex ion. Show clearly the shape around iron 3 and which atom is a ligand are attached to iron 3. So we have to draw a complex structure here, structure of a complex. When a coordination number is 6, means like when 6 dative bond it is forming or 6 ligands are attached, what will the structure? The structure should be octahedral. How we represent an octahedral structure? So we have Fe is there, and water is attached, like here H2O. One is it in, another one is out. And the charge, because water is a neutral ligand, so the charge will be 3 plus, or plus 3 will be there on the complex. So it's important that you draw these wedges and dots to show how the geometry of this complex appear to be. The next is the following equilibrium occur in aqueous solution suggests why one of a water ligand loses proton. So Like why the proton is removed or why the H plus sign is removed. So the main idea is that look, when the water, like if this was a structure of a ligand, so what will happen? This iron, this iron will, this is a water molecule. Lone pair is there, and this is partial positive, partial positive. Now what will happen? The lone pair is actually attracted. Like if we draw in the side which is facing, so because the lone pair is attracted towards the iron, and that is a dative bonding. Now what will happen? This iron plus 3 charge is there. As a result, what it will do, it will attract the electrons. And this is having a smaller size and a greater charge, so it will have a greater charge density. So as a result, what it causes a polarization in a water molecule. Polarization means like the uneven distribution of electron. As iron 3 is attracting, so these electrons are attracted, this electron is also attracted. So as a result of attracting the electrons, the bonded electron, it makes these bonds weaker. So this proton can be lost easily from the water. As you can see here, like there were 6 water molecule, but one of the water loses proton. Why one of the water loses proton? So the reason is that because iron 3 has a greater charge density, and as a result of a greater charge density, it called greater distortion to water molecule. As a result, the bond become weaker, and it release H plus, or you can also say proton. So the distortion to the bond causes a bond to break down easily, and that is responsible for releasing a proton and making a solution acidic. That's why like iron salt solutions are usually, iron 3 salt solutions are acidic. Aluminium chloride, AlCl3, and iron 3 chloride can both be used as a catalyst in a Friedel-Crafts reactions. The reaction between benzene and a chloromethane using aluminium chloride as a catalyst is summarized. Suggest by reference to the electronic structure of AlCl3 and how AlCl4 ions are formed. So we have to explain the formation. This is a Friedel and the Kraft reaction that we will discuss in the reactions of benzene. But here it's not like question is not related to benzene, it's related to how AlCl4 is actually formed. So what actually happened here in AlCl3? AlCl3 is not an ionic compound. Like it doesn't, even though aluminium metal and chlorine non-metal, but it's not an ionic. How AlCl3 is formed? Aluminium share. This is exceptional. Like few exceptional compounds are there. This is aluminium share 3 electrons. So this is how AlCl3 is formed. And but how the structure will be stable? That is by forming a dimer. Like there will be another AlCl3 molecule. Like here chlorine, then aluminium will be there, and this chlorine will have a lone pair, so that is attracted and this is attracted. So that will, like two molecules, they will form a dative bond with each other as a two separate molecule, AlCl3. They form a dative bond with each other. As a result, they make this compound stable. So, but if we have alone AlCl3, the configuration of aluminium is 1s2, 2s2, 2p6, 3s2, 3p1. So electron in a box model, when we represent electron in a box model, so 1s2, 2s2, and 2p6 means first they will occupy a single and then a pair up. Then there will be a pair, and this will be a single electron here. Now, how the structure will be stable when it will form the bond with the chlorine, like forming a covalent bond. So how covalent bond can be formed? Like one chlorine, example, one chlorine is there. This chlorine will be attracted here, form a covalent bond. Another chlorine, and to make it more stable, this electron, because it is forming three covalent bond, to make it more stable, this electron jumps here. So one chlorine will form a bond here. One chlorine will form a shear electron here, another chlorine shear electron here. So now these two are occupied, but what is left is this one. So there is incomplete 3p orbital. So as a result, if this incomplete 3p orbital is there, so if there is a chloride ion, when we say a chloride ion means it already have its electron, extra electron. So it will take both of these electron and occupy this orbital. That's how the AlCl4 can be formed. So AlCl3, when it's a sharing of electron, one of the s electron jumps to p, and now three electrons are available. So three chlorine will form a bond with aluminium, but still there is an empty 3p orbital, and that 3p orbital can be occupied by two electrons. So this chloride ion is having extra pair of electron, one extra electron, but there's a pair available. So that pair will just attract it towards this empty d or empty p orbital and will make it more stable. So how we write this? So aluminium AlCl3 is having, as you can see, empty p orbital is there. And as a result of this MTP orbital, like it has a MTP orbital, so what will happen? It can adjust two electron, or it can accept a pair of electron from the chloride ion, which makes it more stable. Is it clear? Any doubt in this part? The formation of AlCl4 from AlCl3. The next question, thiocyanate ion SCN are used to test the presence of iron 3 in an aqueous solution. A blood red color cause the complex is seen, as you can see here. State the type of a reaction that take place. So what kind of reaction? It, because there might be acid-base reaction or a ligand exchange. But you can see if it was an acid-base reaction, then it will be occupied by more hydroxide. Like it will turn into Fe, OH3 will be there, and H2O3 will be there. If we convert Fe, H2O6 into this substance, if hydroxide, like three protons are lost, so that is an acid-base reaction. But now another ligand is attached here instead of water. So what we called it, we call that as a ligand exchange. So if it turned into a hydroxide, then it will be acid-base reaction. And if it does not, like if any other ligand is, it's not like all should be replaced. Even if one is replaced, then we also call a ligand exchange. Draw a dot and cross diagram of thiocyanate ion. Hence suggests a structure of the ion showing all the bonds which atoms have a negative charge. So we have to draw the structure of SCN, and we have to show we have to state what will be the structure of this. So we have SCN, and the net charge is negative. If a net charge is negative, means there is already extra electron present in the structure. When we represent the sharing of electron, example, nitrogen share 1, so carbon will share 1 from that side. Nitrogen share 1, carbon share 1. Nitrogen share 1, carbon share 1. And there will be lone pair on nitrogen because nitrogen belongs to group 5, so it share 3 and unshared will be 2. So nitrogen is stable in this regard. Now what about sulfur? Because now carbon we are left with only 1. So if carbon form 1 bond, sulfur will form 1 bond. But sulfur, because sulfur belongs to group 6, so it must be stable. Like belongs to group 6, it share 2 electron, but here it is sharing, it share 2 and unshared will be 4. But still we are left with another pair. How this, if still we are left with another electron. So how this will be stable? So means this sulfur has gained an extra electron. That's why the charge on this whole ion is -1 or 1 minus. Like nitrogen is stable because it is forming 3 bond. Carbon is stable because it is forming 4 bond. Sulfur is not stable because in the beginning it's forming 1 bond, but it should form 2 bond. But if we have sulfide ion, which is example -2, so -2 means like it has 7 electrons, 1 it took extra, and 1 is available, so that 1 it uses to form a bond with carbon. So this is a structure of thiocyanate ion. And what will the geometry? Because like it will be S, C triple bonded with N. The central atom, one side one bond and other side triple bond, but we consider when we are predicting a geometry, we consider them as one, so there will be a bond angle of 180 degrees, or it will be a linear structure. State 2 ways in which a thiocyanate ion could bond to iron 3 in the complex. So how it can form a bond? Because the complex ligands can form a bond by like dative bonding is there. Like it form a dative bonding with a lone pair. That is one thing. Or it can also form a bond with nitrogen to an empty orbital of iron. Like because if you see the structure, like when we drew the structure, this was a structure we drew. The structure was sulfur, carbon, and nitrogen. So there's a lone pair on nitrogen and there are lone pairs on sulfur. So it can form a bond, dative bond with a lone pair of a sulfur, or it can form a dative bond with lone pair of nitrogen. So two ways it can form a bond. It can form a dative bond with the lone pairs of sulfur and nitrogen. So one mark is for mentioning because the dative bond can be formed by the lone pairs. In part F, aluminum hydroxide is amphoteric. Write an equation for a reaction of aluminum hydroxide with hydrochloric acid and with sodium hydroxide. State symbols are not required. So we have to show amphoteric means it can act like an acid or it can act like a base as well. So if we have aluminum hydroxide is there, and first we want to show that it is acting like a base. So it will form a salt and water. But this is only ionic equation. Like we have aluminum hydroxide. And if it react with hydrogen, proton, or example HCl, if I write, first I'll write a complete symbolic equation. So what it will form aluminum chloride, AlCl3 will be there. Acid react with the base, it will give salt and water. So 3 hydrochloric acid, because the equation must be balanced. And water, we have 3 multiplied by 2, 6 and 3. So this is balanced. Now, what is the state? So this is amphoteric hydroxide. Amphoteric oxides are insoluble. So solid, aqueous. Most chlorides are soluble, aqueous, and water is a liquid. So when I cancel out the common ion in aqueous, chlorine will cancel with chlorine. So what is the ionic equation? Aluminium hydroxide plus hydrogen ions, the protons from the acid, produce aluminium ions plus 3 ions plus 3 water molecules. So this is what I have to write. The first equation I wrote just to explain the idea that what will be the ionic equation, because when acid react with an alkali, it will form salt and water. That's the first thing. The second one is when aluminium hydroxide is acting like a base. So, sorry, this is acting like a base. If it is acting like an acid, means reacting with alkali. So, if it is aluminium hydroxide is there, react. If I write the equation, so sodium hydroxide plus aluminium hydroxide, so this will result in a formation of sodium aluminate. NaAlOH4 will be there, product. Now, writing the same idea, if you want to write an ionic, this will be solid. As alkalis are aqueous, this will also be a soluble. We cancel the common ions in aqueous solution. So sodium ion will cancel with the sodium ion. What we are left with? We are left with aluminium hydroxide. The hydroxide, as a result, it will turn into AlOH4. And what is the charge? Because aluminum is +3 and hydroxide is -1. So the total net charge here will be, because -4 plus 3, so the net charge will be -1. So this is an ionic equation when aluminum is reacting like an acid, reacting with an alkali. So if you see this question, like multiple parts are there and the weightage in exam is also higher as compared to the other parts. So this was question 14, which was related to the electrode potential and the transition metals.